Hey everybody, greetings from Manjunath. In this video, I want to ask you, what is the real meaning of R squared that you talk about in regression techniques? Let's just say I have a simple linear regression model and that is therefore would have one y or dependent variable and therefore one x or independent variable. What is R squared in this? The textbook definition goes like this. R squared is the percentage variation explained in dependent variable by the independent variable x. So that's a classic textbook definition. I want you to go deeper than that and ask even more pertinent questions as to what does R squared really mean. Let's just understand this. I want to leave it a little open-ended and I want to do a follow-up video to clarify this further, but I want you to hear me out in this till the end. Let's just say R squared for y is equal to mx plus c. Let us say my x is discount variable and my y is sales. And R squared would be 0.45. R squared can go between 0 to 1. Closer to 1 is what is intended, but you got to be suspicious about when R squared is getting close to 1. It could be due to spurious correlations or due to some confounding variables. Coming back to the point here, if R squared is equal to 0.45, how do you interpret? 45% of the variation in sales is explained by the discount variable alone. That's again the classic textbook definition. Yeah. So going beyond that, how do you improve the R squared? If I were to ask you, the simplest answer could be to add more variables, because R squared would have the tendency to increase as and when more variables get added to the model mix. Mind you, I'm not talking about adjusted R squared. How do you improve adjusted R squared? Adjusted R squared is improved only when the variables added is statistically significant. Unlike the R squared could fast approach 1 as and when you keep adding more variables. You know what? I'm not going to do that way. I'm going to do something different and therefore ask you certain questions for your involvement into this. Think about this. I'm going to improve R squared dramatically by not adding more variables, but in fact by removing the coefficients. What do I mean by that? Let's just say I'm going to make the intercept, one of the coefficients in the regression formulation, 0. Now, dramatically, R squared goes up. Let's just say R squared goes up to 0.9. What's happening here? For a moment, I didn't add more variables to increase R squared. Rather, I removed the coefficient and made the coefficient 0. Voila, R squared dramatically shoots up to 0.9. Now, I can think of arguing 90% of the variation in sales explained by my independent variable discount alone. Doesn't make sense, right? Something going on here. What is the phenomenon going on? I want you to apply your minds and then let me know in the comment section down below as to what's going on. I shall reveal the proper answers as to what R squared is in the real sense in the next video as a follow-up. Looking forward to some interesting thoughts, interesting anecdotes if you have any to share, or some interesting comments to see what's your current level of understanding. Thanks for hearing me in this video. Thanks for your patience. This is Manjunath signing off. Bye-bye and take care.